Okay, here we go. Our objective for today, I can solve and graph linear functions. Read together, 1, 2, 3. I can solve and graph linear functions. So we already started yesterday. Just to recap, that's why I'm not going to have you do notes on Cornell. We're going to do that on the graph. So before I move forward, I want you to copy the objective at the bottom left of that graph paper, under the graph, just so that you know what our objective for today is. At the bottom left, which is under that graph or the coordinate plane. And today we're moving on just to close this linear functions and linear equations section, because we already learned yesterday how to graph using what method? Using a table, right? So, so we found out what linear functions were. We covered that yesterday. Relations that assign exactly one output value for input value. In 2 variables, and they have a slope called the constant rate of change. I gave you guys some samples, some non-examples, and we said that that these are non-examples because they have exponents greater than 1. This one because the x repeated here and here, but the y were different. And here because in order for me to place a point here and here, they have the same x value, and you can't have 2 y values per x value. We got some hashtags. We wrote down step 2. Remember that? So basically, step 1 says write a rule for the function. That we're going to leave for a little bit later. Tell whether your graph is a function. We're going to cover that today once we graph. And then we're going to evaluate the function after writing in function notation. So yesterday, we introduced this kind. Remember that? Yeah. Y equals 2x plus 1. And then from there, we actually got an input-output table going. We did x, y, and what was the domain that we used? -2, -1, 0, 1, 2. We substituted values in here, got our values from here, so that became -3, -1, 1, 3, and 5. We plotted those. And then once we plot them, they look something like this, and our line, and we said we put arrows at the end because they continue forever. Remember that? And then from there, I gave you guys this one, and we said, well, this one we needed to solve for y. So this kind I'm recapping for some of you that missed this, 15x plus 3y equals 9. So to solve for y, I need to leave y by itself, so I subtract 15x. This becomes 3y equals -15x plus 9, divide by 3, y equals -5x plus 3, and then again you do your table, plot your points, and so on and so forth. You guys remember that? Yeah. All right, so write this next example at the top of your graph. Example 1C. So let's see. So you wrote this on top of your graph, yes? Example 1C, graph x equals -2, tell whether it represents a function. To the right of the graph, I want you to make a table, x, y. However, for this one, instead of writing well, I'm going to write my domain, but make sure you write it in pencil because we're going to erase. All right. So check this out. Look at this equation, though. X equals -2. Does that look familiar? Not really, because it's missing what? The y. But it does have it. It's just invisible. Let me show you where it's at. Here it goes. I'm going to rewrite this above. Watch. X plus 0y equals -2. Why doesn't it show? Because what is the coefficient?
No.
0y. Everybody with me? So watch. But now that we don't have the y, all we have is x equals 2. So if x equals -2, then y, I can write whatever I want because it doesn't really exist, right? So therefore, I'm going to write -2 here. Hold on. -2. So when y is -2, what is x? -2. How about when y is -1? What is x? No. -2. That means we need to change this, right? -2. When y is 0, what is x? -2. When y is +1, what is x? -2. And when y is 2, what is x? -2. Okay, let's plot those points and find out what that looks like. Got -2, -2, it's right there. -2, -1 is right there. -2, 0 is right there. -2 and 1 is right there. And -2 and 2 is right there. Draw your line straight through those points. So I'm going to do that in red. There it is. Yes, sir.
A better way to word it is that y does not have a assigned value or any method to find that assigned value.
Thank you. All right, here we go. And this one, guys, this is not a function. Let's look at the table. Do any of the x values repeat?
Yes.
Yes, all of them, right? Do I get the same output every time? No, that's why it's not a function. Now let me illustrate using the mapping diagram for those of you that still don't see it. Here it goes. What is the domain? -2. Do I write it all these many times? No. On this side I have -2, -1, 0, 1, and 2. This one goes to this one, but it also goes to this one, also goes to this one, and this one. Therefore, this is not a function. Another way of looking at it is looking at our graph. Look up. Who notices that all the 5 points are stacked together? What is the x value for all of them? -2. And what is the y value for all of them? Different y values. That's why it's not a function. You understand? All right. This kind of graph has a specific name, and it's called a vertical line. A vertical line. And not a function. So, x equals -2. Here's my vertical line, and it's not a function. So, without making a table, get your ruler, and I want you to sketch me the line at x equals 3. Everybody got it?
Yeah.
So let's see. This one was x equal -2, and it's crossing at -2. Therefore, the other one has to cross at what? At 3. Is that a function?
No.
No, because if I place points, all the points are going to be what? Stacked one on top of the other. Does everybody hear it?
Yes.
So once again, what did we learn? Vertical lines are not functions because the x value repeats, but the y value has different values per. We got that?
Yes.
All right, next to that, I want you to write this next equation. Y equals 8. Y equals 8. Let's make it. Yes.
The answer is
Hold on to it. Let people digest that. Eric, question. No, on the same side. X y. Our domain is -2, -1, 0, 1, and 2. So let's see. Look at our equation. When x is -2, what is y, everyone? 8. Very good. When x is -1, what is y? 8. When x is 0, what is y? 8. When x is all the numbers, what is y? 8. All right, let's plot those points. -2, 8. -1, 8. 0, 8. 1, 8. 2, 8. Let's graph our line. And what do you guys notice? It goes through all those points, but it's one kind of line. It's a horizontal line. All right? So now let me ask you this. Is this a function? Okay, let's see. Let me go back to the previous one. The other one, we can tell that it wasn't because the x repeated and the y's had different values. Let's look at this one. Do the x repeat? No. Therefore, this is a function. It is a function.
I have a question because that if the same input gives you a different output, then should it also be not a function if a different input gets you the same output?
No, it's saying that if for the same input you get a different output, then it's not a function. So let me ask you this, Julian. If I was to substitute again the -2, what is y? Is it different? Is it different? That's how you can check. If the x repeats and it has a different output, then it's not a function. But here it's the same, therefore it is a function. Okay? Yes, it does. All right, graph me this next one. Y equals -2 without using the table. Just get your ruler on the same one. Yeah. Give me a second. Let me get a coordinate plane. I got it. Here it is.
And does not have an x function in there anywhere, then
It is.
x equals will be not a function.
Thank you. All right, here we go. So everybody has the flip side right there, yes? Okay. I want you to draw the next graph like I do. I know it's not going to be as nice as mine or perfect as mine, but try your best. Here we go. I'm going to start at -10 and -2. Then I'm going to go up like so through 5. I'm going to curve down and cross at 3. Curve back up and cross at 1. Like that. Yeah, just it doesn't have to be exact. Let me zoom in a little bit. Is that better?
Yes.
Okay. Copy that on your paper, freehand it. All right? So watch. If you are given a graph, doesn't matter what it is. I just sketched this graph. I just made it up. Okay? If you are given a graph and they ask you, is this a function? Let me show you an easy way of knowing if it's a function without making a table, without doing any computation. The easiest method is this next one. This is called the vertical line test. What is it called? The vertical line test. So what is a vertical line? Show me with your hand what a vertical line is. Like this, right? Straight up and down. Not like this. This is horizontal. It's like this. So we're going to draw a vertical line. You get your ruler, and I want you to draw a vertical line going through x equals 1. X equals 1. So I'm going to draw mine going through x equals 1. There you go. That's my vertical line. I want you to do the same. Going through x equals 1. All right? Now that you drew it, let me show you why this is not a function. If our vertical line intersects whatever graph more than 2 times, it is not a function. Here he goes. Here's my vertical line. It intersects that graph here, here, and here. Do you guys see that? Yeah. Okay. If you don't see it, let me accentuate that with points. Here, here, and here. Do you guys see that now? Yeah. So this red line intersects this blue graph at those 3 points. What does that mean? Let me show you so that you see with numbers. This point, my goodness. This point is, what was the x value? 1. What is the y value? 6. 1, 6. What is this one? 1 of x. What is the y value? 4. And this one is 1, 2. Do the x values repeat? Are the y values the same? No, they're different. That's why this is not a function. Yes? No, you can scan it from left to right. How about here? Is it a function there? No. How about, is it a function here? Yes. But since this is part of the whole thing, so if I start from left to right and I scan it, let's see. It is a function there. Yes, 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 yes. But as soon as I hit here, guess what? Not a function. Everybody understand? Okay. So now watch. Let me zoom in, and I'm going to sketch another graph. Don't do this just writing utensils down. Look up. Watch. Here's my graph. From where you're at, I want you to scan it with a vertical line test without drawing it on your paper, but from there, what can you do? What can you use? Look at you, Leanne. What is she doing? Using the ruler as a vertical line. Yes, so scan it. Does it touch at 2 or more points? No, therefore that is a function. Everybody understand? Here, if you don't see it, let me draw my vertical line so you guys can see it. Some of you are using your ruler, some of you are using your pencil, whatever it is. 1 point, 1 point, only 1 point all the way through. Only 1 point. Do you ever see that it only intersects at 1 point all the way through? Therefore, that is a function. This is a function. Let me give you another one. Last one before we move on. Here you go. Here it goes. Tell me if this next one is a function. Use your ruler. Does it touch at 2 spots? Yes. Then it's not a function. Here, let me move my vertical line. this one touches here and here. Do you guys see that? Then it's not a function. And that's how we can check if a graph is a function or not without doing any mathematics. Does that make sense? All right. So with that said, on the blank space that you have to the right, the last part that I want to cover is this next part. I want you to, this is our map where we're at so far. Today I'm going to talk about standard form of a linear equation. So write down this, standard form. Write this down, standard form. And underneath that, you're going to write AX plus BY equals C. Now, how does that look with numbers? It looks like this. Negative 2X plus 6Y equals 12. What do you guys notice? Number one, that it's in alphabetical order. Do you guys see that? And number two, that both variables, X and Y, are on the same side. Let me show you how this looks with the variables on the other side. 12 equals negative 2X plus 6Y. Is it in alphabetical order?
Yes.
Are X and Y on the same side? Yes. All right. So, copy this. It says, write X, write this down. X equals 2Y plus 4. All right? And we need to change this into standard form. So line down the equal sign. The Y needs to be on the other side. Is that correct? So what do? Minus 2Y minus 2Y. So then we write X minus 2Y equals 4. Is it in alphabetical order?
Yes.
Are X and Y on the same side?
Yes.
All right, so now let's identify what A is, B is, and C is. Watch. I'm going to write AX plus BY equals C. What is A? 1. What is B?
2.
Negative 2. And what is C? 4. And that's how you do these. Standard form and identify A, B, and C. We'll continue that on Monday. Have a good 3-day weekend, guys. Hopefully I'll see you at the Brawley Cattle Call Parade. Yeah. Bye. Have a good one. See you guys till Monday. Bye.